Good afternoon, everybody. Time again for Chem 170 Organic Chemistry with your host, me, Dr. White. Sad news, this is our last meeting together. Remember, tomorrow there's no lecture or anything. Just at 1 o'clock, I'm going to send out the email with the password for the final exam. Right now, the final exam is available to download in D2L in the assignment area. But I hope you had a fun time this semester. For those who've been here with me, I hope you enjoyed it. For those who watched the videos, I hope you enjoyed it too. Now, what I'd like to do today is finish up my review of the whole semester. But before I do, some advice for the final exam. One, remember there's 4 bonds to carbon. 4 bonds to carbon. Check your work. You see 5 or 3, it's wrong. Check that. Next, do you break carbon-carbon single bonds except for combustion? No. So don't. Remember, you don't break carbon-carbon single bonds except for reacting something with oxygen, combustion. And the third thing I want to remind you is look for, and when you look at an organic molecule, look for something different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, that's where the fun is. So be sure to look at a molecule and look for what's different. All right, now, if I remember correctly, yesterday I finished off. You take a tertiary amine alkyl halide in the presence of base. Uh, I better do this one last time. Thumbs up, people. Do you see that on your screen? Thank you, Joanna. All right, you make a quaternary ammonium salt. Now, a great way to make a primary amine is take a nitrile, carbon nitrogen triple bond, react it with excess hydrogen, a catalyst, nickel, platinum, or palladium. Remember, this has 2 pi bonds. When you hydrogenate it this way, you put 2 hydrogens on each atom of the triple bond, carbon, nitrogen, and you get a primary amine, which you can also write like this. Now, amines are bases, and bases react with acid, HX, and here I'm going to, for this class, I use X equal chlorine, bromine, or iodine, hydrogen, halogen, other acids too, but I'll stick to this. And let me move this out of the way. You can start with a primary, secondary, tertiary amine. Remember, R prime and R double prime can be hydrogen, proton transfer, and you make an amine salt. Now, I talked about another functional group called the amide. And the amide has a carbonyl with an R group, nitrogen, R prime, and R double prime. Both R prime and R double prime can be hydrogen. How do you make an amide? You take a carboxylic acid, react it with either ammonia, NH3, that's when R prime and R double prime are both hydrogen, or primary, secondary amine, and you make an amide. Well, let's try this one out. We have got to let you have some fun the last day. And the question would be, what's the organic product or products for the following? 3 points each. Your turn. And when you're done, give me a thumbs up. Boy, my class this morning at the other school, well, it's introductory chemistry. Those people either don't know how or don't want to or other reasons do their thumbs up. And almost all of you are done. I'll give you a little more time. All right, let's go forward. Look for what's different. Ooh, carbonyl hydroxyl carbon, carboxylic acid. Carbon, nitrogen, ooh, an amine, which I can write like this. I remember R prime and R double prime can be hydrogen. And what do you get? An amide. In this case, here's my R group. R prime, I'll call methyl. One of these hydrogens is R double prime. So what I get, my R group, remember you don't break carbon, carbon single bonds, carbonyl, nitrogen, and I have on there a methyl and a hydrogen. It's one way. You could have written it also this way. And either way is correct because I know that. Now, once you make an amide, remember proteins are held together by amide linkages of the amino group of one amino acid and the carboxylic acid of another. You make connect them protein amino acids together. Now, once you take an amide, you can react with HCl and water. Where can you find that? Your stomach. And what you get back is the carboxylic acid you would have used to make that amide, plus not the amine. Remember, an amine is a base. In acid, you get the amine salt. So let's try one of those. And why don't you try this one? Have some fun on the last day of class. What would be the product or products of the following reaction? Doesn't it feel good? You learn organic chemistry, and hopefully it wasn't too painful. And for those who finish early, please be patient. I try and give everybody time to finish. I think everybody's finished, so let's do this. What's different? Carbonyl, nitrogen, carbons on the nitrogen, I'll call R prime and R double prime, carbons on the carbonyl, and we have an amide. And we reacted with HCl and water, acid and water. What do you get? You get the carboxylic acid you would have used to make that amide, plus not the amine, but the amine salt. Now, you don't have to put down charges, but I always do. Good habits are hard to break. This is R, and this is R prime and R double prime. Therefore, the carboxylic acid you get is acetic acid. Remember, that's in vinegar. And the amine you get, no, you get the amine salt, I'll write it here, would be, notice you add 2 hydrogens, so I'm going to write it this way. You could also show each individual bond, and that's the products you get. And remember, this is a reaction how you digest proteins, acid hydrolysis of an amide. Now, if you take an amide and react it with base and water, you don't get the carboxylic acid because in the presence of base, the carboxylic acid forms the carboxylate anion of the carboxylic acid you would have used to make that amide, but you do get the amine that you would have used to make that amide. Now, in this chapter, we also talked about heterocyclic compounds. And you should know a heterocyclic compound is a compound, it's a ring, cyclic, with carbon atoms and other atoms such as oxygen and nitrogen. I only asked you to learn one heterocyclic. That's where it looks like benzene, but one of the carbons has been replaced in a ring by nitrogen. We call that pyridine. And pyridine is a very useful chemical, even though it stinks to all high heck. Think of putting a dead fish in a plastic Ziploc bag, leave it in your backyard for 2 weeks, and then go smell it. Pyridine is worse, but it's a useful compound. All right, since I don't have a problem set, I would like to go through, because there are going to be about 4 or 5 points in the final exam on amino acids, peptides, and proteins again. Now, an amino acid is a compound that has both an amine and a carboxylic acid. Now, I have it drawn this way, but a better way, I think, nowadays for me to show you is this is an amino acid. And the carbon attached to the carbonyl carbon, like in a ketone, is called alpha carbon, and that always has the amino group NH2. Now, as you learn for test number 4, chiral carbon has 4 different groups, 4 different atoms, or combination of 4. And this carbon, the alpha carbon, is chiral when our, and that's math, is not hydrogen. Anything else is chiral. So all but one amino acid is chiral, which I have here. And I'll skip this. When you make an amino acid, react it with another amino acid to make a peptide, all you're making is doing an amide reaction. And when you take a protein, which is this 50 amino acids held together by amide bonds, when you eat it, you're really doing acid hydrolysis of a amide. Now, leaving my class, there are a number of things I hope you know. Hint, the first one is, how does soap work? Oh, wrong thing. And the answer is, first of all, what is soap? Soap has a nonpolar tail. and a polar head. Water, which you use to clean things, is polar. Dirt is nonpolar. And as you learn, the most important piece of the puzzle here is like dissolves like. And that means things that are polar are soluble in polar things, things that are nonpolar are soluble in nonpolar things. Try to mix the two together, they're not soluble. Well, if you have dirt on your hand, you're trying to get it off, and we magnify that piece of dirt. It's nonpolar, and water looks at that and says, I want no part of you. I know like dissolves like. I'm polar, you're nonpolar. Stay away from me. And they do. But if you wash your hands with soap and water, the soap molecules, the nonpolar tails, are attracted to the dirt, and the polar heads want to stay as far away from that because the like dissolves like. And now you've made, and you should know, this is a micelle. Excuse me. And a micelle now looks polar. Because on the outside, totally surrounding the dirt, I'm just showing a couple, is the polar heads of the soap. And now water looks at that micelle and says, oh, you're polar, I'm polar. I know like dissolves like. Let's go down the drain together. And they do. And that's how you get your hands healing. So you should know how soap works. Soap, nonpolar tail, polar head. Water is polar, dirt is nonpolar. Like dissolves like. What happens is when you use soap, you form a micelle, which has this structure, and it looks polar to water. And therefore, because the like dissolves like, the dirt and water, really the micelles, go down the drain together. That's how you get your hands clean, or anything else. Now, another thing I would like you to know is how to describe with words in a general reaction what happens when you eat something that has a fat or oil in it. And what's the functional group in these? Ester. And therefore, when you chew it and swallow it, goes in your stomach, and that's got acid, hydrochloric acid. It's got water, so it's acid hydrolysis of, and the functional group in ester. And the general reaction you should know, you learned for test number 3. Take an ester, react it with acid and water, you get back the carboxylic acid you would have used to make that ester, plus the alcohol you would have used it. And that's what happens when you eat a fat or oil. And that's how you describe it with words and with a general reaction. You should also know how to describe with words and a general reaction what happens when you eat a carbohydrate. And we're really talking starches, which are carbohydrates. And what's the functional group that holds glucose together in a carbohydrate? And that is an acetal. And in your stomach, there's acid, There's water, so it undergoes an acid hydrolysis and the functional group you're breaking down to get glucose from starch is an acetal. And for test number 2, you learn take an acetal or ketal, react it with acid and water, and you get back the aldehyde or ketone you would have used to make that acetal or ketal, plus the alcohol you would have used. And for those who like to put a 2 there, you can. I don't. Can I make it any smaller? I'll try. But you should know when you eat a carbohydrate, how to describe it with words, acid hydrolysis of an acetal, how to describe it with this general reaction. And the final food group I'd like you to know is when you eat something with protein in it, eat a protein. And here, what's the functional group you should know that holds amino acids together in a protein? And that's the amide functional group. And when you eat something with protein, your stomach has acid, hydrochloric acid, and it has water. And what's the functional group? An amide. And when you take, this is how you say it in words, the general reaction you learn for test 3. And here you have to remember, use HCl, that's in your stomach, acid and water. You get back the carboxylic acid you would have used to make this amide, plus you will get not the amine, but since you're an acid, amines are bases, and therefore you get the amine salt of the amine you would have used to make that amide. So once again, the 3 major food groups or areas are when you eat a fat and oil, the functional group is an ester. That's acid hydrolysis of an ester. And there is ester, general reaction, acid and water gives you a carboxylic acid and alcohol. When you eat a carbohydrate, the functional group that holds glucose together in starches is an acetal. Therefore, you have acid hydrolysis of an acetal. That's how you describe what happens when you eat a carbohydrate with words. And the general reaction is acetal or ketal, acid and water. You get back the aldehyde or ketone plus the alcohol you would have used to make that acetal or ketal. In this case, it's glucose where both of those are connected together. And finally, when you eat a protein, what's the functional group in a protein? Amide. And here, what's in your stomach? Acid and water, so it's acid hydrolysis of an amide. And the general reaction is amide plus HCl and water gives a carboxylic acid plus the amine salt of the amine you would have used to make that amide. Now, on Monday, I just went through the whole test number 4. So essentially, let me just do something. Hold on once. I'm going to go through real quick because we just went through it when I went through the answers on test number 4, but you should know what is a polymer, macromolecule made up of repeating units. You should know the chemical properties. There's addition polymer, only one type of monomer used. Condensation, two or more different types of monomers used. Examples of an addition would be rubber tires or your saran wrap, plastic wrap in the kitchen. Condensation, my plastic water bottle or yours or a pop bottle. And then when it comes to polymers, there's a physical property, thermoplastic. Once formed, can be reheated and reshaped. And again, plastic water bottles example there. Thermoset, once formed, cannot be. Oh, hold on. I need some water. All this talking. Test, ketone, it works now. All right. Once formed cannot be reheated or reshaped, and that would be car tires, urethane foam. We talked about fats and oils. What's the saponifiable lipid? Fats and oils, non-saponifiable steroid. Remember, a fat is a solid or semi-solid room temperature. Oil is a liquid at room temperature. And I showed you, this is a standard triglyceride, 3 or triester of a fat and oil. And if you have acid hydrolysis, here's what happens. You get back glycerin plus fatty acids. Base, you get back glycerin plus the carboxylate anions of each ester. Don't forget what you're seeing on the screen is available for you to download from D2L, the lecture folder. And remember, steam is hot water, and you get the same products as acid hydrolysis, but it's cheaper to do. You don't have to buy hydrochloric acid, that's why. And you get back the alcohol and the carboxylic acid you would have used to make that. So for a triglyceride, you get glycerin and 3 fatty acids of our prime and our double prime are different. I taught you 2 fatty acids, saturated, which means no double bonds, carbon-carbon double bonds. Stearic acid, you should know that structure. Oleic acid has a double bond at C9, and you should know that structure. And the difference between a saturated fat, only carbon-carbon single bonds, unsaturated fat, at least 1 carbon-carbon double bond. I'm going through this fast because we just went through it on the test, but you should know tallow is beef fat, white grease, yellow grease, pig's fat, and my designation for white grease, yellow grease, and tallow is this triglyceride, R sub S, R sub O, R sub S. Therefore, if I were to write tallow, say sodium hydroxide and water, what I'm really asking is this triglyceride, sodium hydroxide and water, each ester will give you the alcohol and the carboxylate anion of the carboxylic acid used to make that ester. And you get glycerin and sodium stearate and sodium oleate. Talked about how soap works. I've already done that. And remember, you should know how to draw the ring skeleton, the 4 rings, 6, 6, 6, 5 of a steroid, all steroids, which I talked about. Then we talked about carbohydrates, the definition of a carbohydrate. Then we shifted to chirality, means handedness. We went through, and you did quite well on that. What's a chiral object? It's an object with a non-superimposable mirror image. A chiral object is an object that has a superimposable mirror image. And then you learned how to circle the chiral carbons in a molecule, and that's carbon atoms with 4 different groups, 4 different atoms, or a combination of 4 different atoms or groups. Wow, whoever did these reviews did a good job. Thank you, Dr. White. You're welcome. Anyways, Also, you learned about an enantiomer. That's a non-superimposable mirror image of a molecule. And if I asked you to draw the enantiomer of the molecule, you learn from test 4 and what I taught you in this chapter, you draw the mirror image. Now, here's 2 important equilibrium you should know. You take an aldehyde or ketone, alcohol plus acid catalyst, get an acetal or ketal. But since the alcohol and glucose is in the same molecule with the aldehyde, you don't need acid catalyst, you have an equilibrium, and you get this hemiacetal, or the, I think it's called glucosidic form of, glycosidic form of glucose. And if you do fructose, same thing, except now you have a ketone, carbonyls here, and you get this hemiketal. Now, as I taught you, you take a hemiacetal or ketal, react it with a different alcohol, instead of 2 of the same, you get an unsymmetrical acetal or ketal, where you replace the OH group on the carbon with the OR with OR triple prime. And for the cyclic form of glucose, this hydroxyl group is replaced with OR triple prime. And this is the mechanism we connect glucose molecules together to make starch. And you should know table sugar is sucrose, which is made up of fructose and glucose. Would I ask that on a test? I did, test number 4. And starch is a polymer of glucose. Therefore, if you take 50 glucose, react it with acid, you'll get starch. And because the linkage is an acetal or ketal between starch, or in sucrose, fructose, and glucose, acid and water give you fructose and glucose. Starch, acid, and water gives you glucose. And then I've just gone through how to describe with words or and a general chemical reaction, what happens when you eat a fat or oil, and what happens when you eat a carbohydrate. Now, at this point, we hadn't talked about amino acids and proteins, but now you should add that too. The first day of class, I said, my world of organic chemistry is your world of organic chemistry, but you don't know about it yet. Now, if I've done my job right and you've done your job right, my world of organic chemistry is now your world of organic chemistry. One of the things my father always told me and beat my head was, one thing somebody can never steal from you is education and knowledge, which has always been true. And now you have knowledge that most people in this country, probably in this planet, don't know. You know the basics of organic chemistry and how it applies to your daily life. And that's a wonderful thing to know. Plus, organic chemistry is a lot of fun, but I'm biased. I'm an organic chemist. Let's go out into the real world and find out if I'm lying to you or not. Now, I've mentioned before patents. Patents are a way, and this is not going to be on a test or anything, but patents are a way of protecting what's called intellectual property, an idea or concept. One of those is a molecule I made. And chemical patents, there's 3 types. One is called composition of matter. Here's this molecule, it's mine, but you have to show utility, why it's important to be patented. The second type is called an application patent, where you can't say this molecule is mine, nobody else can use it, but I have some molecules, if I do this for this sort of thing, like a fabric softener, nobody else can use it for that application. And that's a very powerful patent. And the last one is the third type, which is not that powerful, and most time you don't get that alone, and that's called a process patent. To make this compound, you do this, this, and this in a chemical plant. But it's still protection you like to get if sometimes you put all 3 together in a single patent. Now, where do you find patents? The most useful site other than Google on the internet for me personally is the United States Patent Office, Patent and Trade Office. Is, let me, yep. Thumbs up, people. Do you see where it says search for patents? And let me go back one. If you go to Google and put in USPTO, you'll get this. And if you click on search for patents, it will take you here. Now, since I know about this, I can teach you. I used to do a lab with students and they hated it, so I dropped it. But anyways, see where it says USPTO, Patent Full Text and Image Database. Click on that. You'll come to this screen. See where it says searching full text and patents. I like using advanced, and you get this interface. And I usually spend, when I'm working on certain projects, at least 20, 30 hours a week on here. It's chock full of information. And you can put various things in here to do a search. And I did. And the search was, let's go back. I know how to, these are the search terms, quaternary, and IN is inventor, white, IS is state, Illinois. And if I go down here, click on this is a US patent, and I click on images. Does anybody see somebody's name familiar with? Keith and I, our patent. Now, look over in the abstract. Can you see this on the right? A novel composition, this is a composition of matter patent, the strongest, of a quaternary ammonium salt. That's my invention. I told Keith, you should make it, because I wasn't working in that area in our research group, so that's why we're together on the patent. And instead of R sub T, we just put tallow. And do you know what kind of molecule this is? A quaternary ammonium salt. And the R group here, you see a methyl, methyl, tallow, and this is 2-ethylhexyl, and you see X minus. Now here we defined X minus as chlorine, iodine, bromine, but also this is a sulfate, which is useful too. And this is a patent, and guess what? You can see that. Now let me show you something about patents. You have the most important part of the patents are the claims. And see what's claimed? A patent is this compound. And now you can understand what that is, that it's a quaternary ammonium salt. And now I know, and I think you know, my world of organic chemistry is your world of organic chemistry. I'm done. I've done my job. And I know from test scores, you've done your job, which makes me happy. For those of you who've been coming to my lectures live, thank you. For those of you who've been watching my lectures on YouTube, thank you. I'm done. It's the end of the summer. Boy, does summer go quick. Again, I'd like to thank all of you. And with that, don't forget, tomorrow at 1, I'll send out the password for the final exam. You'll have till Friday morning, 10 a.m. to finish it and upload it. I highly recommend get your labs in too. If you're missing any labs, get them to me. Otherwise, you're going to lose points and that's going to hurt your grade. And because we've done all the labs, normally if we were face to face, we'd go into the lab and you check out, but we don't have to check out. I'm done. And with that, I'll say, unless you're eating soybeans, stick around for a second. I'm going to say, gang gesund, be healthy, goodbye. And don't forget, it's getting nasty out there. Wear your mask again. If you haven't gotten vaccinated, get it. It's free. It's available everywhere. Get it. It'll keep you alive. I heard a sad story on the news yesterday where, thank you, Sandra. And oh, one thing, if you know anybody anywhere in the United States who needs organic chemistry, I'm teaching it online just like I did this semester, summer, this fall at Elgin Community College. And I'll do the same thing, post live stuff on YouTube. With that, oh, and if you ever need any help with anything, always feel free to email me. If you have any questions about organic chemistry, always feel free to email me. With that, gehen gesund. Bye.